matrices for regression. All right. Now, if we have data x1, y1, x2, y2, xn, yn, so we have n-ordered pairs. One of the first vectors that we're going to look at is a response vector y. And guys, a y vector is nothing more than, this is going to be a column vector. And it's going to be nothing more than our y values. Okay. Another matrix we're going to look at quite a bit is a design matrix. And guys, we're going to call this matrix X. And again, considering our data that we have x1, comma y1, x2, comma y2, up to xn, comma yn, our design matrix is going to be an n by 2 matrix of the following. See, I told you these ones in the first column were actually going to show their eerie head. So again, design matrix looks like this. Now, guys, our model is in the form of y sub i's equal the expected value for y sub i's plus our errors for each term. Guys, that should be an I. So we can get an expected value matrix, which is actually going to be a column vector. And we can get an error vector. And it turns out that the error vector is in n by 1. And let me go back. And obviously the expected is n by 1 too. Okay. So this is our error vector. I don't think I gave. Yeah, let's give this a name. I don't know. It's just vector of whatever. Well, I mean, not whatever, but just call it whatever you want to. It's the vector of apples. Well, no, it's not. It's the vector of mean responses. So let's just kind of settle on that. And obviously, it could go by other names as well. Now, kind of putting all this together, with y being the expected value plus the error, we can look at this in this form. Which, from what we said, if we have the same size, so we have what, an n by 1 and an n by 1, we could clearly, I'll tell you what, let's do. Have this equal to that matrix. Now, you know, let's just say we've got x1, y1, x2, y2, and x3, y3. Let's simplify the notation here. So we just have 3 ordered pairs. So we could multiply this times our beta matrix, and I'll probably call this most of the time the parameter vector. And you can see from what we know here, you know, here we have a 3 by 2, and here we have a 2 by 1. So the inside parts are the same, so we can multiply these things together, and of course we're going to get a 3 by 1 matrix. Well, using you know, linear combination, we're going to take the first entry times the first entry plus the second entry times the second entry. Then we're going to concentrate on this row, this column. So we're going to take beta 0 plus beta 1 x2. And of course here we're going to have beta 0, beta 1 x3. Now there would be nothing to say that we can't generalize this. And to generalize this, obviously, this matrix is going to be an important matrix too, as you might imagine. Okay. And then when we split that up and look at some stuff, it's going to play an important role. Now, there's 2 matrices that I want us to examine. Actually, no. There's 3 matrices. And I say, you know, important. I mean, hell, everything's important, but the three that are really important at this stage. One of the first matrices I want you to consider is, you know, for the response vector. And it's transpose. So what is this vector going to look like? What's the product of the y transpose times y going to look like? Well, remember the y vector. Look like this. So the transpose has to look like that. So we have here, we have a 1 by n, and here we have an n by 1. So the product matrix here is going to be a 1 by 1, and what's it going to look like? Well, linear combination, boys and girls. First entry times the first entry. Second entry times the second entry. And so on. Which obviously is just going to be the matrix of the sum of our y values squared. Another matrix I want you to have on your radar is x transpose times y. Now let's go back and think about what x looked like, our design matrix. Remember, it had all those ones in front. I don't know how far we got to go back here, but goodness gracious, I've done a lot. All right, so our design matrix is a column of ones and then our x coordinates of our ordered pair. So should be no surprise to anybody that x transpose is going to look like this, and our y vector going to be a column vector that looks like this. So boys and girls, we're going to have a 2 by n, and we have an n by 1. So our product matrix is going to be a 2 by 1. So we're going to have 2 rows and 1 column. So linear combination of the first row with the first column is going to give 1 times y1 plus 1 times y2 plus 1 times y3 plus 1 times y to the n. Guys, there should be no doubt in your mind this is just the sum of the y's. The next we're going to get x1 times y1 plus x2 times y2. So there really shouldn't be much debate about what this is. It's just the sum of the products of x sub I times y sub I. The other matrix I want you to kind of have on your radar, and the one I almost forgot about, is what does x transpose times x look like? Well, x transpose is 1, 1. And of course, x is Now, first of all, let's examine the size that we're expecting. So here we have a 2 by n. Here we have an n by 2. So guys, we're expecting a 2 by 2 matrix. All right, let's examine this. This is going to be a linear combination of our row 1s and column 1. So if we examine our row 1 with our column 1, we're going to get 1 times 1 is 1, plus 1 times 1 is 1, plus 1 times 1 is 1. Okay, I'll stop. So 1 plus 1 plus 1 plus 1 plus 1, n times is just n. All righty, let's examine this part. Well, this is going to take row 1, column 2. So when we examine row 1 with column 2, we're going to get 1 times x1 plus 1 times x2 plus 1 times x3 plus 1 times x4. Am I annoying yet? Plus dot, 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 1 times xn. So, boys and girls, this should be no surprise to you. That's just the sum of our x's. The bottom left entry is going to be row 2, column 1. So now we're concentrating on row 2, column 1. Oh, we get the same thing, don't we? We get x1 times 1 plus x2 times 1 dot, 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 xn times 1. So guys, there's no doubt that we get sum of our x sub i's again. And finally, we're going to examine row 2, column 2. So that's going to be x1 times x1. Let's think about this. So we have x1 times x1. And then we get x2 times x2. And finally, way out there, we're going to get xn squared. So boys and girls, there should be no surprise here that we get the sum of the x sub i's squared. Well, I could just keep going. I just actually love this stuff.